I know that most of you know how to do all the standard addition and subtraction, multiplication, division algorithms for our numbers already, but there are probably a few minor nuances that you don't ever really think about when you're doing them, that are actually very important when you're first learning these things, which is important for you to understand both one as a teacher. You want to understand like what is like kind of hard about these things or what is nuanced about them. And also for the next section, we're going to start doing this stuff in other bases so that you can really fully understand what is so hard about this stuff. So when we're doing 15 plus 21, this is like one of the easier problems to do. Because if you were to represent these numbers with base 10 blocks, so I have one group of 10 and 5 extras, 5 singletons, and then I have 2 groups of 10 and then 1 singleton. If I wanted to combine these into a base 10 number, I can very simply just combine all the 10s together and then combine all the 1s together. And now I have 3 10s and 6 singletons, so I have 36. Where it gets more involved is when we start having to carry or make exchanges. So if I want to do something like 15 times 27, what's going to happen with this? So if I tried to do the same sort of thing, just combine all the 10s and combine all the 1s, and then write down what that number is, of course, I would have 3 10s, and how many 1s would I have? Well, I would have 12 of them, right? And so we don't have like a digit for 12 or something like that. So what we have to do is make an exchange. So what we're going to do is take 10 of these and then group them together and exchange them for a group of 10. So we make what's called an exchange right here. And so we would say that we have 4 10s and then 2 extras left over, so 42. So the whole point of this is we're trying to make exchanges. Okay, let's go another step up. If I want to do 136 plus 265, so I have 100, 3 10s, 6 extras, and then 200s, 6 10s, and 5 singletons. And if I want to combine all of these, we're going to very quickly notice that we're going to have to do a bunch of exchanges. So I like to go right to left. This is kind of what happens when we do our standard addition algorithm as well, when we sort of line everything up and then add things. So we would combine all the 1s together, and then we would realize, well, how many 1s do we have? We have 11. And so what we do is we sort of make an exchange right there. What that looks like for us usually is we carry the 1. So we would take 10 of these and swap them out for a 10. So I'm just going to do that. I'll just put that right here. And then I have, how many 10s do I have? Well, I have that 1 that I carried over, the 3 from the first number and the 6 from the other number. And so how many does that make? That makes 10. So I have 10 of them, but of course I will want to do an exchange for these as well. So since I have 10 of these, I'm going to exchange these out for one of these hundreds. And so now I have 100 plus 2 from the other number plus 1 from carrying it over, and so I have 401 total. Okay, and so that's sort of what's going on when we do that sort of algorithm. All right, subtraction is very similar, except with subtraction, you don't actually want to represent both numbers with base 10 blocks. You just want to represent the number that you are starting with your base 10 blocks, and then you need to take away some number of base 10 blocks. So here I have 34, Okay, and so I just need to take away 12 and see how many are left. So I'm going to take away, I need to take away 110 and 2 extras. So I take away 110 and then 2 extras. And how many am I left with? Well, you can see that there are 2 10s and 2 extras, or 2 singletons, so this would be 22. Right, so this is the 12 that we took away. This is gone, and this is how many we are left with. This is 34 minus 12. And of course, this will get more complicated when we start having to make exchanges. So if I do 314 minus 136, I need to take away 100, 3 tens, and 6 singletons. So let's work from right to left, because again, when we do this in our standard algorithm, usually when we make exchanges with this, we work from right to left. So the first thing you do is notice, well, I need to take away 6 ones from the 4s, from the 4 ones, and so I need more. I can't do that. So I have to take this 10 right here and exchange this for 10 singletons. Okay, so I'm going to bring these up here. So I'm making that exchange right here. So this is still the number 314, but I made this exchange right here. And now I have enough to take away 6. So here's 6 that I'm taking away. I'll just put that off to the side. Okay. And so now I have these 8. So I took away 6. Now I need to take away 3 10s. Can't do that. There are 0 10s here. So I have to take one of these hundreds and make an exchange for a bunch of 10s. So let's bring that up here. Okay, so I just exchanged one of the hundreds for 10 10s. Now I need to take away 3 of these 10s. So let's do that. Let's take away 3 10s right here. Okay, so far we've taken away 36, and I need to take away 136, and now I can really just take away the last 100 right here. So I've taken away 136, and how many am I left with? I'm left with 100, 1, 2, 3, 4, 5, 6, 7 10s, and 8 ones. So I should get 178. And this process is mirrored in our standard subtraction algorithm because every time that I do an exchange, we are borrowing from numbers here. So when I do 4 minus 6 right here, I want to take 1 away from this, so this will go down to 0, and then this will now become 14 because I borrowed 110 to make 10 singletons. So I have 14 and then minus 6. I have 8. That's that right here. And then I don't have enough 10s right here for this column to take 3 10s away. So I have to borrow from the hundreds. So I take 100 away, and now I have 10 10s instead of 0 10s. So I take away the 3, and I'm left with 7. And then I do 2 hundreds minus 100, and I get 178. So all of these steps are very much mirrored by this whole exchange process that we do with these base 10 blocks.